How's it going, you guys? In this video, we're going to be talking about solving systems of equations. In particular, we're really going to be using a lot of graphing to do this. So, really easy. Essentially, a solution to a system, will have like two or more equations, and it's just the point or points, there may be sometimes multiple points, that these things meet each other. So, they would have the same x value, the same y value. There would be one point that is in common with both of those. Sometimes they can have the entire graph is in common, they would have infinitely many, or sometimes they can have nothing in common and there's no solution. The first thing we need to review real quick is how to graph a line. So please don't forget for me that we have something called y-intercept form, or slope-intercept, I don't know what it's called, but essentially we have y equals mx plus b, where m is our slope, or how much we go rise over run, and b is our y-intercept. You guys should remember this from Algebra 1. If you don't, come talk to me. We can work on it some more. Because this line, we should be crossing the y-axis at 4, so I can put a point at 4. Now my slope is -2, so I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, to infinity. Alright, such that I have that line right there. Make sure you put a lot of good points, because the points is actually how we are going to get our solution. So the more points you put on your graph, the better off you will be, I promise. All right, the other line, we will have to graph that as well, and we're just looking for the intersection of the two. That's all that a solution would be. So -3, so I'll cross at 1, 2, 3, and then my slope is 5, so I can go up 1, 2, 3, 4, 5 over 1. Well, hey, that was nice. So once I get to a point that I have, that means they meet at this point right here, right in the middle. So that point where they are both equal to each other, both of those lines are equal to each other, they have the same solution, is our solution to this system. So I just have my x value is 1, my y value is 2, so I have the point 1, 2, that is my solution for that problem. That's all we're going to be doing. So, similarly, we have -x minus y equals 2. So the only issue with this is it's not in this form. It's not in y equals mx plus b form. So if I solve for y, so we could add the x to both sides, such that this is -y equals x plus 2. And then this negative in front of the y is still an issue. So if I multiply by -1 or divide everything by -1, either way, that will give us y is -x minus 2. And then I can graph that line because it has an y-intercept of -2. The slope is -1. So it's doing something like that forever. I'm just going to turn it sideways so I can graph my line. Being very careful to go through the points that it's going through. You can get a straight edge, you can get a ruler, whatever you want to help yourself graph that. Alright, but there would be our first line there. This other one's just y equals x, so that's easy. I mean, it's like we don't have a y-intercept, so it's almost like saying 0, so we can start at 0. My slope is up 1 over 1, or I can go back, so there's my point right there, that'll be my solution. I have this line there, I have a solution right there, and my solution is -1, -1. You'll state it always as ordered pairs for us. Alright, that's pretty much it for graphing. So looking at this one now, we have a word problem. You might see something like this, hint, hint, wink, wink. It says, suppose 30 members in your class went on a rafting trip. Class members could either rent canoes, I will call that C, for $12 each, or rent kayaks, I will call that K, for $20 each. Class spent a total of $456. How many people rented canoes? How many people rented kayaks? So we want to know how many canoes, how many kayaks for $456. So if I want to do that, I know I have 30 people altogether, so I know the number of canoes plus kayaks is 30 people. I also know that the canoes, for every canoe that I rent, it's going to cost me $12 plus 20 times each kayak, and these together will total $456. I'm going to remind you guys of another way that we can work these problems without graphing. It's called elimination. So if I eliminate a variable, remember I can multiply this one by -12 such that when I distribute this -12 throughout my problem, I will be able to eliminate my c's and I will only have k's left. So I have negative 12c minus 12k equals negative 360. So if I add these equations together, 12c goes away. I'm left with 8k equals, oh, what is that, 96? Yes. And then it's super simple, because you have 8k equals 96. Well, just divide both sides by 8. That tells us that k equals 12. So if I know k is 12, and altogether there were 30 people, then that must mean that there were 18 people that bought canoes. So that's each for that. Good to go. Take your time, really make sure you make sense of it before you start trying to work something out there. It's really, coming up with the equations is sometimes the hardest part. Solving is not usually that difficult. All right, we have, without graphing, does each system have 0, 1, infinite, or infinitely many solutions? Start, rewrite equation in slope-intercept form. So slope-intercept form is just this form and this form, y equals mx plus b. So with this one, if I have 2y minus 10 equals 6x, I can add the 10 and divide everything by 2 so that y equals 3x plus 5. That's my first equation. This other one, I just need to add the 5, y equals 3x plus 5. Whoa, I thought I just wrote that, right? And that's that equation. That's that equation. Well, they're the exact same. So if they're the exact same thing, all that means is that these are the exact same line. They are always on top of each other. So if they're always on top of each other, then every solution is a point. So this one would have infinitely many solutions. Oh, that's not right. It's about spelling infants. Infinitely many solutions. Right? If you're not sure how to spell it, you can always look up there. That's what I did. I cheated. I cheated! I did it! Alright, I'm going to do the same thing. Going to solve this equation for y, and then we'll solve this equation for y, and see what our equations look like together. So with this one, I'm going to add the 3x, so 6y equals 3x minus 12, divided by 6, so y is 1/2 x minus 2. My other equation, I just need to divide by 2, so y equals 1/2 x plus 2. Alright, so here, again, without graphing, these equations are different. They have the same slope. This is the same in both of them, but their y-intercepts are different. So they're parallel, but they have different y-intercepts. So this one, first one, and then the second one would be doing something like that. Parallel lines, as far as we know right now in life, they never cross each other. So if they never cross each other, that would mean that we actually have no solutions here, because there's no place that they intersect. Plus. All right, you guys are doing awesome. We're almost done with this one. We only got 2 more. Last thing we're going to talk about in this video is solving with systems of inequalities. Just like solving for equations, except there's going to be lots of places that this can be true. So we want to have our y values less than x. Let me zoom in a little bit if I can. A little bit. All right. We want our y values less than x, and we want also y to be greater than or equal to 3x minus 1. So let's just start easy. Let's start by graphing this line. Y is less than x. Well, that would have a y-intercept of 0. Remember, we are less than or equal to, so remember from Algebra 1, please, that that line is solid. If it is just less than, that is when we will have a dotted line, because we are not equal to that line. But in this case, we are. We can be equal to this line, so it says y can be greater or less than or equal to x. We can be less than or equal to this line. Now reading that too, it says less than or equal to, so I need to be all my y values less than that line. So a shortcut way to pick that, if you pick a point anywhere, this y value right here is 1. The y value is less than 1 would be below. So since that one's below, I need anything below that line to work. All right, my other line is y is greater than or equal to 3x minus 1. So 3x minus 1 will have a y-intercept of -1, and my slope will be up 3 over 1 the entire way. again, it's less than or equal to, so this will be a solid line as well. Beautiful. Beautiful. Now it says greater than or equal to this line, so pick any point. Say I pick this point right here. My y value there is -4. The things greater than -4 would be up here, so I could have anything up here. Now just like equations, we just want the part where they intersect or the part that they meet. So this one is above this line. It's up here, it's in blue here. The other one is below this one in brown. It's all down here. But I only want the place that they are both true to be shaded in, which would be this portion right there. So I could pick anything in there. So let's see. If I choose -2, -3. If I want to see if -2, -3 works in both of those. So I have a y value of -3. Well, if I put in -3, -3 is less than -2, 3. So it's good for that equation. I know it works there. -3 is greater than or equal to 3 times -2 minus 1. That's -3 is greater than or equal to -6 minus 1. That would be -7, so that is also works. If you're ever not sure where it is, like I say, you can pick any points. So say if you picked a point out here, say we chose 2, 0. If I put in 2, 0, y is less than or equal to 2. It would work for that. This is checking if 2, 0 works. Does it work? Put it in here. 0 is greater than or equal to 3 times 2 minus 1. 0 is greater than or equal to 5. That does not work, so I know for sure that is not a solution. You don't have to go through and check points, just make sure you're very careful in your shading. All right, we'll do one more, and then we'll be done. So we have 2x plus y is greater than 3. So again, we need to put this in slope-intercept form. So this function, or this equation, will be y is greater than -2x plus 3. This one, I need to subtract my x, so I have -y is less than or equal to, just less than, -x plus 2. Now this -y presents us an issue because we need to divide by -1. You also have to remember that anytime you multiply or divide an inequality by a negative number, it changes the direction of our sign here. So this turns into y is greater than x minus 2. So anytime you multiply or divide by a negative number, change the way that the inequality is facing. Please, 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 please. That's just a shortcut. It's kind of a little trick for you. So we have slope or y-intercept of 3, slope of -2. So now with this one, notice we are just greater than this line. So when I draw this line, I cannot be equal to this line. So I need to have a dotted line because I cannot be equal to it. Anything that we cannot have, we will make dashed. It says y is greater, so pick a y value, 3. Anything greater than 3 would be like 4, 5, 6. So I know for this line I can be anywhere over here. Could be. Now I need to graph my other line. X minus 2. So -2, my slope is 1, up 1 over 1 to infinity. We are greater than, so I will make this dashed as well. And we are greater than that line, so we could be anything up here. These two intersect in this area right here. So that would be the final answer that I'm looking for. We can have any solutions in that part. All right, hopefully this video was helpful. Please, 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 please come ask me questions. You guys are working on it. All right, I'll talk to y'all soon. Bye-bye.